So, we will be at the end of the second week with this lecture. 6 lectures done, 30 more to go, but who's counting? Right. And this week you will have on Friday the tutorial, right? With today's lecture, in particular the part about functions, call by reference, which is to be introduced today, you will have everything you need in order to solve your assignment 1 part 1. And with today we will finish basic syntax, C++ issues. On Monday we talk about memory management, a little bit of pointers again and how to handle them. And then on Wednesday we start talking about classes and continue on Thursday and next week, and all that material will be used for assignment 1 part 2, where you will solve the same problem but using classes instead of structures, so you can compare what happens when you move from C type approach to C++ approach. So this is what happens. Your assignment 1 part 2 will, I haven't started talking about the new stuff. For assignment 1 part 1, I will go over what I think is good for you to pay attention when you submit your assignment on Thursday, next week. Next week on Thursday, I will have some time allocated in the lecture to answer questions for assignments and try to point out what we will pay attention to. And then on Monday, after the assignment is due, which is due not this Sunday, next Sunday, on Monday I will go over some parts of the solution where I think might be useful for you. We don't give sample solutions for any assignment, and 2 reasons. One is that there are many possible approaches. That's fine, as long as it works and you did what was required in your solution. You will have comments if something went wrong. This is one reason. The second reason, we end up with some solutions online if we give solutions, and this is something which is not very nice, because we tend to reuse some assignments, change them a little, but who knows, might be reused. I try to vary them a lot. And assignment 1 part 2 will go out on Monday after the due time for assignment 1 part 1. And you will have 2 weeks as well. It will be due Sunday in 2 weeks. So roughly speaking, it's kind of every 2 weeks you will have an assignment. Be aware that the assignment 1 part 2 is due on Sunday, and on Monday you have the term test. So it will be kind of a busy time because you have to revise for the test, and I will talk about the test review and what you have to do on Thursday before the test. I will point out, but in principle you have everything we will cover till the test, from the first lecture till the test review on Thursday before the test, everything, which in fact is everything before inheritance. Everything. Tutorial questions, lecture notes, and your assignment 1 part 1, assignment 1 part 2. This is what you have for the test in principle. So what we talk about function and call by reference is one question of the test. And I have put online at the moment an example of a program using call by reference. I just added it today. And I will put some questions for you to practice with call by reference. But we will come again on this test issue. I think we can start now. I promise that I will show you some way to validate input. And the main issue is if you write something and I expect an integer from the user, then in many cases the user may not pay attention and enter wrong data. One way to deal with that situation is put in place some code to check that the data is an integer. And there is, as I said, no flush for the input stream. The simple way to flush the input stream is declare a dummy string variable, read the whole line into the dummy string variable, and in this way you flush out the input stream. Because everything is under the string umbrella, so flushing the input stream is just reading everything which is in the string buffer or whatever into your dummy string variable. But if you want to do some input validation, this is one approach. We don't talk about the string flags. C++ has some string flags, but they are not covering situations in which you expect an integer and the user enter an integer .79. You can't deal with that situation just using what tools are provided by the language. So here, as you can see, we use a string, string, as you can see, input string. I talked about this yesterday, previous lecture, yesterday. To do something like that, you read everything as a string, and then you go and check every character in your string to be a digit. IsDigit, the lovely function from C, gives you the way to work. And if so, you go with a for loop to check that what was entered by the user is a digit, in other words, part of an integer. And if this happens, then you change that string into an integer. NH is declared an integer. Where I declare it? Yes, at the very beginning. So if everything goes, I will go in detail here. If everything goes well, we change from string to integer. Last check an age, because here we are talking about age, but if you are just checking for integers, this is not necessary. If the value is negative, it's not a valid age, and we go again through the while loop. Otherwise, if the value is positive, we are here. Now, this small program demonstrates the use of break and continue, which probably were used before, but I'm not so sure if you have used it. So it's a good way to try to see how they are used. Now, as you can see, we have here a while loop which doesn't take any variable of Boolean type. It gets performed all the time. The way to get out of this loop is using break. So be aware, break takes you out of the inner loop or the current loop you are there. We have a break inside the for loop. This takes you out of this for loop, but it keeps you inside this while loop. And this break is the one which takes you out of the outer iteration. Continue does a different thing, skips the next iteration. So continue here says, okay, if you have entered an integer, I haven't covered this, but that integer is negative, skip this part and go again here, ask for an integer, right? So continue jumps at the beginning of the next go through the loop. Have you used them before? Continue and break?
Yeah,
You might find that
use break but not continue.
Continue skips the next, the current iteration, skips whatever is here and takes you to the next go through the iteration. Okay, so let's see. Assume that the user enters something which is not a valid integer value, something like 12.9, assume. With this statement, we read 12.9 and store it in this string, right? And then we declare a flag, Boolean type, to control where we are going. So, the value enter is valid, is set to true here. And then we go inside the loop and we go through each character in the string. Notice string length. You go from the first character up to the last character, not including Z, right? It's less Z. And for that character, we check if it's digit, the current character. If it returns true, if it's a digit, what happens? This is false, therefore this is skipped, right? Because this is false. So if the current character is a digit, this is false, and we are out of the loop. The for loop has only one statement inside, right? So if everything is a digit, we get the thing. Remember, this was true. You are out of your for loop. Be valid is true. Therefore, non-be valid is false. Therefore, this is skipped, right? So we are here. All were digits, so we have a valid integer. And with this, the string is used to convert, the string variable is used to convert that string made up of digits into an integer, and we get an age number. And if it's negative, if the number is negative, we go here, enter your age, and we go again, because it's not a positive value. If the number is positive, this is false, this is skipped, and we are here. So, remember, we said we have digits only, positive, it means a valid age. And with break, we skip, we are getting out of this loop, and we are here. Now, assume that when we go through this, we encounter one character, can be the first, the second, or the third, one character which is not a digit, right? Assume the third character is not digit. If everything is digit, we go inside the loop. But assume that the third character is not a digit. We have something like 2, 3, 8. Because this is digit is false, not false gives you true, be valid is set to false. right? We have found something which is not part of an integer, and we get out of the for loop. With this break, we get out of the for loop. B valid is false. This, because B valid is false, non-B valid is true, therefore we go here, continue. And continue takes you inside the next iteration, which means ask again for your age. Right? So this is a program, and enter your age. Let's say we enter 45.8. What happens? Dot, which is a third character, is not a digit. We are here, therefore, B valid was set to false. We get out of the for loop. This evaluates to true, and we go here. And this is why we got to enter your age. Right. Let's go to the other case. Let's enter something like this. With minus 67, everything is a digit. So we are out of the for loop because everything was a digit. B valid was true because it was true set here and it was not changed. Everything. B valid is true. Well, we have continued here with minus. Minus is not a digit.
You were going to say how does minus work?
Minus is not a digit, right? So we are, it's interesting. We are still here. The first one is encountered and is not a digit, and we are getting there. So this part probably should be dropped.
You just need to check it with 0.
0 is a valid number, not an age, but we can check just for. No, newborn baby is a 0 years old. So we can accept the zeros. Right, let me see. We can put something there, but anyway, 78 will give us the values. Problem is with this one, if we get this out of here, do we get what we want without getting? Anyway, the thing is, with this, you sure check for only integers. But the question mark is, do we have to check for negative values? Probably not, because minus can get here already covered. So, the thing is, you have to go through each character and play with break and continue. The program is online. See how, if we delete this, what happens. And then you can change it to check for float values. You can check for is digit or is the dot, because you might accept float values. If you want to check for float values, you have a similar approach, but accept not only digits, one dot coming from the real representation of numbers will have to be accepted. Other than that, if you ask for strings, everything is a string. So these are, in my view, what you have to check. If it's an integer or if it's a float value. For strings, you don't have much to check, and everything can be read as a string. This would be one way to check the validity of input value. Oh, I have closed the GCC, which I did everything. Right, let's go for these functions we are covering today. And we have to look at new additions to the C language. We talk about inline functions, overloading, extensively used in C++, reference variables. Again, you have seen something about reference variables with pointers, but C++ has a different way of calling by reference. And the last new addition, default raptors. So the functions are organized like in C. Every function has to have a name, a return value, and no or one or more arguments. In C++, and for your assignment, you will be asked to write first the function prototypes. And for the function prototypes, you can add or ignore the name of the variables. The name of the arguments are needed when you define the function. At this stage, the compiler needs only the types to check the types when you invoke your function. So sometimes in some examples I have seen integer here is called x and then a is used, and the compiler doesn't matter, doesn't care, because it doesn't look at x. This option is perfectly acceptable, and it doesn't lead to any mismatch between numbers, which may confuse the user, the reader of the program, not the compiler. So, function prototypes first with comments. For your assignment, main function, and after main, you do the function implementations or function definitions. And of course, for that function definition, you have to copy the heading, including the name of the arguments, because you use them in your functions. So, for speeding up computation, C use this syntax, preprocessor. Definition, define cube I to be this. It's very fast, but error prone, because the computer can't check, the compiler can't check the types of variables. There is no types here, and you don't have any help from these checkings. To perform as efficient as this code does in C++, a function like this, which as you can see does the same thing like this, can be declared to be inline. So in front of this, inline is written, and the compiler checks the types, which is a plus, and then whenever cube is encountered, it substitutes cube by this expression. In other words, it does exactly like this did, but in a safer way. Functions in line should be short, no recursion use, no iteration. And the compiler can decide, no, your function is too long, or I don't want it. It's too complicated to be in line. So it's just a recommendation. Here, an example of what kind of problems you can have with this. What is the output here?
8.
2. 8. 2 times 2 times 2, cube C1 is 8. What is the output here? Minus 28. Because this is what happens with I being 5 minus 3 times I times I. And then you end this, which is this. If you want to get exactly the same behavior as our function, you have to use brackets. So things become a little bit more complicated with complex expressions. Therefore, the best way is forget about preprocessor define and use inline. We will see that when we talk about classes, some, depending on where you write the function, some are inline already. In C, probably you remember, if you want to perform tasks like very common, print. If you want to print a student, you say print student. If you want to print a course, you say print course, because you can't reuse the name. But in C++, you can use the same name for different functions as long as your functions differ by types. Notice arguments have different types or number of arguments. Here we have 1, here we have 2. But I call all of them print. So if I have a student type or student structure variable, I can use print with no extra inclusion in the name and passes a student variable. And if I have a course, I can use print course variable. Same name, easy to remember. You don't have to remember these names. So in this example, as you can see, we have here 1 integer and we display int. We have 2 integers and we display both ints. And we have float here. When you use them, again, function prototype, main, and then function implementations, the compiler knows which one to use because it has 1 integer actual value. It calls the first print function, and this is the output. When we use 2 actual values, it calls the second, and for the third, it calls the float one. Right. There we go. Oops. There are cases in which you provide 2 or 3 overloaded functions, but you call it with a 4th type. Like in our example, int, float, and to int, and I call it with a double value. It doesn't match any of the 3 cases we had. And we will see that in that case, the compiler tries to do some analysis and choose the best match. So if there is an exact match, if I have a function print with double, that will be called, which was not the case for us. Otherwise, if we don't have an exact match, tries to promote float to double, short to long, and so on and so forth. Int to float, for example, or if this is not possible, converting float to something where you lose precision. If float to int, the real part is dropped. So you get a little bit of a different value in that case. And with this, you can get into what is called ambiguity problems, where because of the promotion, the compiler doesn't know which one to choose. It can promote int to double and float to double. And and then it tells you, oh, I can't perform the task. So ambiguity thing is an issue, which we'll demonstrate next time, because I haven't put the code here. So be aware, try to make as many functions as required. Functions are not distinguished on the return value. This is not overloading. Only on argument lists. Be aware, the compiler will let you know that this is not allowed. Overloading is a very useful mechanism, and compare what happens in math, in a C, when you use absolute value function, and you forget that for floats you have a different function name, fabs. You are tempted to use the same absolute value, and when you apply it to integers works fine, because absolute returns an integer value. When you apply it to floats, it converts to integers and gives you a different value. While in C++, as soon as you include the proper file, remember, this is not acceptable in C++, this is, then we can use absolute function because of overloading. This returns an integer, this returns a float value, because absolute is overloaded for int, for float, for other numerical types, and therefore you get the correct value for this. You know what absolute function does, right? Returns the positive corresponding value of your argument. Right. It's good not to mix C and C++ if possible. As you can see, we get different values depending on what tools you use, coming from C or from C++. Default parameters is another new feature introduced by C++, and refers to assigning a value to your parameters based on the assumption that that is the most popular case. In this example, we work with power function, and we assume that in most cases that function is invoked for squares, a to power 2. This is the most used function for areas of rectangles of various shapes. You work with a square. For distances between points, you work with a square and then other square root and stuff like that. So, as you can see, that power function, which uses here a recursive approach, we are not going to use recursion in 234 because it's not directly related to what we are covering, object-oriented methodology, but this is a nice example just to refresh your memory. And here, this is the base, and this is the power exponent. So n to the power 2 is computed. If k is 2, it returns n squared, as you see. If k is greater than 2, it calls power n, k minus 1, the precedent value, and multiplies by n. The beauty of this is that now we can call this function with one argument. The second is this one. Therefore, this uses 2 for k, and we get 3 to the power 2, which is 9. But we can ask the system to override that value. So if we want to compute 3 to the power 3, we pass another argument, or 3 to the power 5. We will see that these default parameters are very useful when talking about initialization of types. Most numerical types are initialized with 0, so we will have default values set to 0. There are some bits and pieces. If we have the function prototype, and then after main the function implementation, be aware, the function prototype contains the default parameters which are not repeated in the function definitions. So the default values are mentioned only once. If we have function prototype and then function implementation. This is one issue. The second issue, these default parameters should be filled from the end. You can't have one parameter which is defaulted to 0, second parameter no default value, third parameter default value to 1, because the compiler can't guess which one is defaulted if you call it OS2 value, for example. So if we have 3 arguments, it has to be the last one defaulted. We might have the last and the one before defaulted, and the first one undefaulted, and we can have all 3 defaulted. It's up to you to decide whether you want them defaulted. But definitely from the back to front, trailing parameters may have defaulted value. And with this, you can go again into ambiguity issue. If we have this function with one argument and this function with a default value, when we call it like this, the compiler does not know. You wouldn't know which one to use. So it's normal to understand that this is an ambiguous situation and you have to sort it out. And the third issue for functions is how they use invocation. As you know, the default way for function invocation is called by value. That's right. This is what is in C. It's the same thing in C++. In other words, when you have a function and you invoke it, a copy of the value you use for invocation is created, is used, eventually return if you need it. But when the function ends, that copy is dead, right? If you want to preserve the changes, you have to use a little bit different approach. In C++, we look at this new approach, which is the reference variables. Be aware that for already initialized value, A, it's a variable of integer type set to 10. It's a normal variable. We can create a reference variable in this way. Notice that the address of operator is now used between the name of the variable and the type. It's not used here, because if it's used here, it's a different thing, pointer allocation. But in this case, we say that we have declared an R, a reference variable, which is nothing new. It's just another name for A. It's another name for A. And as soon as you declare it like this, you can't change R. It's stuck with A. So it's an alias for an already existing variable. It's another name for that variable, And if you take the size of operator or try to display the address where R is stored, address of R, you will get the same address as for this one, which tells you it's exactly this operator. So, we will see that these callback reference variables are used for functions mostly. We won't use them in this raw form, like inside main you have this construction. This is not what is called or used, not very useful. So, assume that we have B, another normal simple variable, and we try to reset R. This is not allowed. And this is one of the differences between references and pointers. If you have P, a pointer, which takes the address of A, then you can change P to take the address of B. That's fine. But with references, you are not allowed. So this is one of the differences, be aware. Right, and now, here we have some simple questions to let you know that things can become quite interesting. We have A, that integer, and R is a reference to A, and we display both. Now we get 10 and 10 from here. Now we set A to 3. We get 3 from here, and we get 3 from here, because they are the same. Now we set R to 15. Be aware, R is the same as A. Therefore, this is 15, this is 15. And if we are devious, we can have R2 a reference to R. And now we have R, A, R, and R2 the same memory location reference as this. And if we set R2 to 1 to 5, we get 1 to 5 and 1 to 5 here, which would be quite, if this is set up at the very beginning and this is set up at the end after 200 lines of code, you might get a little bit confused about A being reset. But if you have some memory displayed and try to work properly, you will have good tracking. As I said, this call by reference is used for functions. Instead of using call by reference by pointers, as you used it in C, from now on we will use call by references C++ way. Remember, in this case we have call by value. So this is how the function is defined. Resets A to 5, in fact a copy of whatever is used at invocation time to 5 and displayed. So if we assume that we are here inside main and we have this setup, I is an integer set to 3, we call that function for this value. What happens? This displays 5, right? When the function is called, it displays 5, but I was copied into 3. That 3 was discarded, didn't use a tool. 5 is displayed, but at the end, this value, this copy is dead. So when we are here, we are working again with 3. That's why we get 5 and 3. With this one, because we use call by reference, be aware, this does not create any copy, anything. It's not a copy created. When we use this, the system works with the original memory location. So in this case, we have I here, which was set to 3. When the function is called, a copy of this was created, set up to 3, changed to 5. When the function finishes, this was dead, and when we go back to main, we are back here. But when we are there, the memory is I is set to 3. When the function is called, R is another name for I. Nothing new is created. Therefore, Z3 is changed to 5, like here. 5 is displayed. When the function ends, it ends, and I is displayed, and 5 is displayed. So this is the benefit. No extra memory, and you will see, if you compare it with call by reference by pointers, the syntax is much simpler here. Think how would you do this if R is a pointer to int instead of this. The syntax is much simpler and less error prone. So this was what we had to cover today. We have some minutes, which is good because we have some programs I want to show you. What is interesting here, how to develop safely critical code. So code on which human life depends on. There are 10 rules which were published in 2006. Again, NASA, and in collaboration with GPL Lab for Reliable Software, came up with some rules in 2006. And I would want you to think about these rules when you write code. Avoid go-to and recursion for very important application. All loops must have fixed bounds. While true, which I showed you as an example, is not such a safe because it doesn't have fixed bounds. You go from 0 to 100, and you can do this with while, with for, and all other loops. Avoid heap memory allocation, dynamic memory if possible, because that is very rely on the operating system. Restrict functions to short code. For real application, a single printed page is the size. For 234, a half page. If you have a function more than half page, it means that it does too many things and is too complicated. Try to split it in smaller. Runtime assertion, what is true at the running of the function, we don't. Restrict the scope of data to the smallest possible. Global variables and the variables which are of larger scope are not a good thing to use. Make sure that non-void functions return values. This is one of the common mistakes I have seen. Preprocessor, try to avoid it. Define macros, try to avoid it. Limit pointer use to single dereference. Do not use function pointers, as you can see. Make sure that you understand what the warnings are about, and if possible, try to fix them. Avoid warnings. So this is something you hopefully will use when you start working on your assignment, or after you finish your solution, try to go and see whether you have done good demo references. This is the program you have online, which is swapping two strings, as you can see, and this is good for organizing your code. Function prototype, with comments which are not here. And then this is a code I put on the slide and we went over it, most of it. I have used here now a pointer just to make you aware what is going. And then I have used this function which swaps two strings. And you can run it and change it and make sure that you understand how it works. Now, something which is not in the slides, but it will come up in both final exam and it's online, on stream. C++ introduced a new tool. This double underscore function, double underscore. So be aware there are two underscores here. Gives you the function name when you use it like this. Okay? So what we have here, a function that returns the sum of two integers in add numbers, and this returned there. And inside main, I declare two integers and then a variable to store these values. When this function is called, we get inside here and you will see add numbers appears on screen and we display the result return. So it's good for debugging, but also it's good when you want to see what function are used there. Entering function I have add, and this is what we get, add numbers. Right. So, and then we display the result. Entering function, and this gives you exactly what you have put, we have put here. Very simple syntax, you don't have to include anything, it's part of the standard library, so you can use it. That notation, standard and line, we will talk about it on Monday when we look a little bit at how use name and namespaces can be used. So, it's not a big thing. Notice you can use that one. And the last thing is, call by reference is used in particular when you work with stream parameters. And you should be adventurous and work for your assignment like passing strings to your functions. Notice here what we have a structure with two fields per second, and then I define a function which takes an input stream because it's used to read data, therefore that stream is changed. You have to pass it by reference. Reference iString. Okay? Because I am working with files here, I have included fstring. So our function, as you can see here, does this. Reads data from cout or from file. I use it in main with code. And whatever data is read, assuming that they are integers, are used to construct the pair variable. Very simple. None first, none second. And return that variable. In fact, it returns two values as a unit because it's a pair. Okay? And now, how I use it? I use it with cout. First I display a prompt, and then I invoke our function with standard input device. Right? So in this case, input is seen, and I display whatever was stored in that, whatever was returned, right? So input here is seen read the first, read the second, put them together, and it needs a pair, and then we display them. After that, the same function can be used to read data from a file. I declare the file, and I have created a small text file. If the file is found, right, I invoke our function, and in this case, inf is, input is inf, read the first, read the second, display them. If the file is not found, something is displayed. So, as you can see, this data has two numbers more, but I didn't put any while loop here. So only the first two will be used. They are all in the same directory. So first I am at this part, enter two integers, 34 minus 67. So they are displayed, as you can see, and data from disk file 45 and minus 9. These were read in when I invoke it inside this block, var function int from inf, right? And then the two values are there. Now, for your assignment, you will have to use something similar, but with a for loop to read all, or the while loop to read more lines. So you will see, I strongly recommend for your assignment to use this type of extraction. Don't worry about performing that the integers are numbered or float values. This type of reading. And the first thing for you to try to see whether you can work on that is to use this program and read more line. Add more pairs of numbers here, and make sure that you go with a for loop inside the if statement or whatever, or inside this function, or use a while loop to read more than one line of data. Because your assignment is very similar. You have an integer for ID, some names, but they are all one word. So you can use this approach to read data. Don't get very complicated with reading the whole line and splitting it, because it's not necessary. So this is all, and good luck. See you on Monday, but you have the lab or tutorial on Friday. Remember this. Remember the